Welcome everyone. I hope you enjoyed those whiteboard lectures where we went over the different cycles, and just like we talked about an issue related to the water cycle and the nitrogen cycle, we will also talk about an issue related to the carbon cycle. But before we get there, just a little reminder, I chose this PowerPoint because it shows a bare and rocky barren earth, and again this is what this is what the Earth looked like before there was an ozone layer. Before there was a protective ozone layer, no life could survive on the land due to the mutagenic UV rays. So if you Google climate change, you get a lot of junk out there. So before we can have a serious dialogue about this issue, we need to ascertain what are the facts and what are the uncertainties about global climate change. So a little true-false question here. The greenhouse effect is good for life on planet Earth. Well, hopefully from the last lecture you know that the naturally occurring greenhouse effect is benefit for the life that is on our planet today. That if it were not for the naturally occurring greenhouse effect, that the average temperature of the Earth would be negative 18 degrees Celsius. All right, another little review question. Hopefully you know exactly what fossil fuels are. Hopefully you know the three examples of fossil fuels are coal, oil, and gas. And by gas, I mean natural gas or methane, CH4. So fossil fuels are coal, oil, and natural gas. And does this include gasoline? Is gasoline a fossil fuel? Yes, because it is an oil product. So petroleum, any of the oil products, that is included in this. So gasoline is definitely a fossil fuel. And hopefully you know that. They are called fossil fuels because they're the fossilized remains of plants and animals that lived millions and millions of years ago. So again, another little review activity. You can do this on your own. You should be able to do this definitely by your next quiz. Here are different components of the electromagnetic spectrum. Here are global environmental terms, and you should be able to put them neatly into two categories. So make sure you can do that for the next quiz. All right, so big question. What are the scientific facts regarding greenhouse effect and global climate change? Because again, depending on what news station you listen to, there's a lot of stuff out there, and not all broadcasts are created equal. And as I already said, before we can have meaningful scientific dialogue, we have to agree what the facts are. So, and then also what our uncertainties are. So, fact number one is the carbon cycle. I outlined this in the whiteboard lecture, and this is a fact. We understand the flow of carbon through the ecosystem, and we do know that humans do indeed engage in activities which could absolutely affect atmospheric carbon dioxide. For instance, the combustion of fossil fuels, deforestation. As we deforest, we not only put CO2 in the atmosphere, we also are lowering the rates of photosynthesis, which could put more CO2 in the atmosphere. So the carbon cycle is not in dispute. Human activities are not in dispute. But again, just because we've looked at the carbon cycle and we've said, oh, we would predict, based on our observation of human activities, based on our knowledge of the carbon cycle, even though we would predict that our activities would be putting carbon dioxide in the atmosphere, that is not enough to predict an increase in carbon dioxide. We need data in science. But the activities themselves are not in dispute, and the carbon cycle is not in dispute. All right, the greenhouse effect, that is a fact. This is an observable physical phenomenon, and it's verified probably by your own personal experiences. If you've actually walked into a greenhouse, you know that the interior of the greenhouse is warmer than the air outside. Same thing if you've been, if you're a car owner and on a sunny but cool day, you enter your car, you notice that the interior of your car is warm compared to the air outside your car. And this is even more dramatic on a warm summer day. Your car actually gets really, really hot, much hotter than the outside air. And again, on other planets, Venus, even though it's closer to the sun than we are, the temperatures on the surface of Venus are incredibly high. And again, this is due to the clouds of greenhouse gases. So again, the greenhouse effect is not in dispute. I've never heard anybody say, oh, I don't believe in the greenhouse effect. If they do, I don't know what I'd think of them. These as an observable physical phenomena, which again, that we have reviewed, that in a greenhouse, the shorter wave, the visible light, comes 93 million miles from the sun to the Earth, and the Earth, as it is warmed, reflects the longer wave infrared. Just like the infrared is reflected back by a sheet of glass in the greenhouse, it's reflected back by the greenhouse gases around the Earth's atmosphere. So again, none of this is in dispute. These are observable scientific facts. All right, fact number 3. Does life on the planet benefit from the naturally occurring greenhouse effect? Well, again, we've already covered this. Absolutely. That we've evolved under these circumstances. Now, would life on planet Earth benefit from an enhanced greenhouse effect? Because if humans are indeed causing an increase in carbon dioxide level and more heat is being trapped, then we would have an enhanced greenhouse effect. So this is not, this question is a little bit more nuanced. And so maybe there'd be some organisms that would actually benefit from an enhanced greenhouse effect, but the whole ecosystems in general have been evolved and are balanced at the sort of current thermostatic temp setting. So the question is too much of a good thing still a good thing? So questions we have to answer are atmospheric levels of CO2 really increasing, just like we predict from our understanding of the carbon cycle and our observations of human activity. So are the CO2 levels truly increasing? Then is human activity responsible for them? And then what are the effects of these increased CO2 levels if they are occurring? All right, we're back to facts now. If carbon dioxide levels are indeed rising, more heat is being trapped. This is not in dispute. This is simple physics. You can, an illustration of this, if you are warm under one blanket, if you add a second blanket, you will be warmer. Because a blanket does not produce heat that you feel. That's not how a blanket warms you up. A blanket is simply trapping your own body heat. And are the naturally occurring carbon dioxide levels, while they trap some of the infrared, they don't trap all of the infrared. So this is simple physics, that if you thicken the carbon dioxide blanket around the Earth, more infrared will be trapped. Now, another thing to realize is this, and this is why it's changed, this expression from global warming to global climate change. A lot of people say, well, what's the big deal if we raise the average Earth's temperature by a couple degrees Fahrenheit or even a couple degrees Celsius? What's the big deal? I don't mind if the weather's a little bit hotter. Well, there's two things I want you to think about. One, think about your normal body temperature, 98.6 degrees Fahrenheit. That's your normal body temperature. Is it a big deal if you raise it 3 little degrees Fahrenheit and now you're close to 102 degrees Fahrenheit for your body temperature? Yeah, that's a big deal. You feel a lot different if your temperature is 101.6 rather than 98.6. When you're getting around 102, you feel significantly different. And then again, degrees Celsius are bigger than degrees Fahrenheit. So suddenly if your body temperatures are up to 103 degrees or greater, you're in serious trouble. This is a serious health threat. The other thing I want you to think about is if you take your cup of water and heat it in a microwave, maybe you want a nice cup of hot tea. Does it take a whole lot of energy to raise a cup of water a degree Fahrenheit or even a degree Celsius? No, it doesn't take that much energy. But how much energy does it take to raise all the water in your swimming pool a degree Fahrenheit or degree Celsius? That takes a heck of a lot more energy. Now, if the oceans are actually warming by that, how much energy would it take to raise all the waters of the Earth by a degree Fahrenheit or degree Celsius? Do you see the amount of energy we're talking about? And that amount of energy really cannot be ignored. If we are trapping that much more energy, that it can raise the temperature of the ocean waters, that is a significant amount of energy that we have to deal with. And so that's why all predictions of climate change include worrying about more powerful hurricanes, more powerful storms. And I'll tell you, growing up, I mean, When I was a girl and a teenager, you didn't have to worry every other month. Oh, here comes severe winds, and here's power outage due to winds. And it seems like lately, in the last 5 years, that there has been a lot more damage due to strong winds, and that seems to be a phenomena increasing with greater and greater frequency. All right, so back to this statement here. If carbon dioxide levels are indeed rising, more heat is being trapped. This is not in dispute. Well, guess what, ladies and gentlemen? We know that carbon dioxide levels are indeed rising. Therefore, more heat, more energy is being trapped, and we're having to deal with it. And again, that the carbon dioxide levels are indeed rising, this is not in dispute. So let's look at some important data here. I'm wondering, maybe I will add a comment to see how, I'm really curious as to how many of you have actually seen these data before. This is taken, it's still being taken today. It was started in 1958 by a weather balloon in Hawaii. And this was started in 1958 before global climate change was even a big scientific issue, and definitely not a hot potato political issue. Now, why, if we wanted to measure carbon dioxide levels, why were we sampling the air in Hawaii? So again, this weather balloon goes up and it goes into the atmosphere and collects the air and measures the carbon dioxide levels. So why would you do this in Hawaii and not in Dayton, Ohio? Well, in Dayton, Ohio, if you're measuring CO2 levels, you're basically measuring the result of traffic going north and south on I-75 that day. And when you think about industry, you have sort of CO2 hotspots all over the globe. But if you look at Hawaii, Hawaii is pretty isolated. So, you have your hotspots here and there and your intense areas of CO2 concentration. But you want these to diffuse so you can get a global average. So remember, air, the atmosphere is a solution, and it should be a homogeneous mixture of nitrogen, oxygen, and yeah, there's ozone in there and carbon dioxide. So by sampling their air in Hawaii, we're getting a nice global average, not just how many cars drove through Dayton that day. So let's look at these data again. Now, when I first saw these data, I thought, what? This is what people are getting all worked up about? Look at that variation. Look at that fluctuation. I thought, those instruments must not be very reliable. How can we trust this with that amount of deviation? And then when someone pointed out to me, well, these fluctuations are actually seasonal. So when it is spring in Dayton, Ohio, and summer, global carbon dioxide levels decrease. And when it is fall and winter in Dayton, Ohio, and by the way, the whole northern hemisphere, global carbon dioxide levels increase. So decrease spring and summer, increase fall and winter. It's sort of like the whole earth is, inhaling, exhaling, inhaling, exhaling. You get the idea. Now, what would account for this seasonality? Now, a lot of my students say, oh, humans drive more in the winter because you can't walk as much and heat their homes more. And, that's sort of a typical answer, and it's sort of hard to shake the mindset that it's all about us. But there's actually a more compelling reason. And when you think about it, humans in the southern hemisphere, well, it's winter when down there when it's summer up here. Guess I shouldn't use the words up and down. Anyway, let's talk about trees. In spring and summer, photosynthesis increases, so carbon dioxide levels decrease. Now, again, well, what's the problem? Why is this dependent on when it's spring and summer in the northern hemisphere? Because isn't it winter in the southern hemisphere, and shouldn't those forces even out? Well, what you have to remember is where are the greater landmass? Most of the landmass is in the northern hemisphere, but more importantly, where are the deciduous forests? The deciduous trees are the ones that lose their leaves in the fall and are dormant all fall and winter and then leaf out again in the spring and the summer. Well, as it turns out, 90% of the deciduous forests are in the northern hemisphere. And yes, indeed, when it is spring and summer in the northern hemisphere, global CO2 levels decrease. As the leaves leaf out, photosynthesis increases and suck that carbon dioxide out of the air. And when it's fall and winter in the northern hemisphere, global CO2 levels increase. It's pretty amazing. So if you think about it, the rates of photosynthesis of the tropical rainforest, that's not going to vary much, or of the oceans. But the photosynthetic rates of the deciduous forest, they actually have an observable impact on global CO2 levels. So we sort of have this winter-summer compensation, except it's not being totally compensated. Now, our current lows, so the Earth is not like recouping anymore the way it used to. Our current lows are much, much, much higher than our former highs. So yes, it is very clear that the global levels of concentrations of CO2 are indeed increasing. So, did you note today's level of CO2 on the last slide? How did that compare historically? Sorry about that. Today, the carbon dioxide level in our atmosphere is about 390 parts per million. And that's at the time of this recording. You can follow a link and you can see the daily levels of carbon dioxide as taken by the station in Hawaii. And again, there is a seasonal fluctuation. So I'm recording this in the spring, you'll be listening in the summer, so maybe it'll be a little bit lower. All right, but look at this. We have been able to get ice core data to look at historic CO2 levels. So let's explain this a little bit. So scientists go up to the Arctic and they drill, just what I said, ice core. And this is works the same way as sedimentary rock because it snows every year in the Arctic, and the older layers are down lower and the younger layers are closer to the surface. So the farther you drill, the older the ice. And what we've been able to do is get these this very old ice, and there's atmospheric bubbles, air bubbles, trapped in this ice. And scientists have been able to analyze these air bubbles at different levels and ascertain the percent of carbon dioxide in the atmosphere. And look at this. Through hundreds of thousands of years, there's been this natural cycle of increase and decrease of carbon dioxide. And it's very interesting to notice the parallel increase and decrease of global temperatures. But again, historic highs, I should say prehistoric highs, we're talking hundreds of thousands of years in the past, rarely do CO2 levels get above 280. But our current level, not only is it getting higher than the 280 parts per million, it's up around the 380, 390 range of parts per million. So this high is way outstrips any historic precedents. Think about how our evolution units, how long have humans been on this planet? Humans only appeared on our planet our species about 100,000 years ago. So we are experiencing levels of carbon dioxide that our species has no evolutionary history with. So again, to review, not only the CO2 levels are indeed rising, therefore we do know more heat is being trapped. Now, it's important here to make sure you understand the difference between weather and climate. Weather are your daily conditions, rainfall, other precipitation, temperature, wind. And weather fluctuates widely day to day, year to year. But climate is defined as a 30-year average of weather conditions. And climate tends to be very, very stable. And this has been a good thing because humans became agricultural about 18,000 years ago, and our civilization has depended on stable climate, that we've been able to grow crops in a fairly predictable ways, and our civilization is based on it. But looking 30 years past, all right, the more heat is definitely being trapped and it's being reflected in the temperature. Just in temperature alone, we are seeing very strong evidence of global warming and climate change. Some more diagrams showing averages. It's hard to keep up with this because you get new data every year. I like this because it was still in Colorado. All right, so another thing to review, and this is a fact as I showed you, the Hawaii data is compared to the ice core data. Not only is carbon dioxide increasing, it's increasing at a rate higher than any natural cycle ever recorded. There is no natural cycle that can account for the steep slope that you saw in the increasing CO2 levels. And our current CO2 levels are higher than in all of recorded history. So again, there's no natural cycle that accounts for the steep increase that we've seen just in the last 150 years since the Industrial Revolution in the 1850s. All right, so again, historic data versus, well, this slide is already outdated. We're above 380 parts per million now. All right, again, it's not just a matter of worrying about the average temperature being degrees higher. This is where we get in trouble. Here's another fact. Our climate, or remember, our long-term weather patterns are determined by atmospheric and oceanic convection currents. This is not in dispute. Now, what I'm worried about is that you don't understand the statement. So let's review a little bit. You know that hot air rises, it travels, and then cold air forms. All right, so this whole pattern is called a convection cell. All right, and there are both atmospheric convection cells and convection cells in the oceans too. And so it's these huge convection cells caused by these convection currents in both the atmosphere and in the water that determine climate. Now think about this. If you increase the amount of energy, then the hot air will rise higher, all right, will be in the air longer, and what you're going to end up doing is altering the convection currents and convection cells. And once again, this is not in dispute. Wow, I hate it when I do that. I went to the end of the PowerPoint. All right, so when you add more heat to the system, these convection cells, you are altering their shape. All right, and once again, this is not dispute. If you add more energy to the system, you're going to have an effect. So this gives you the scope of the problem. It's not just a little bit of carbon dioxide is making a planet a little bit hotter. When you change the shape of these convection cells, you're altering these stable climates that human society depends on. And so suddenly, you have places that have always depended on water now experiencing drought because maybe that's not where the rain falls anymore. Or suddenly that you've had dry places suddenly have torrential rains. In fact, that's one prediction of climate models is that you have more torrential rains because greater heat, you have greater evaporation. All right, there's a lot of uncertainty. So again, we're worried about the whole pattern of climate change. This is the other thing I wanted to say about this. The past winter, so winter 2013, 2014, we hit some record lows, and a lot of people are, sorry, not scientists, but some people, just people saying, oh, this refutes, this disproves global climate change because we're having record colds. This Arctic vortex is making its way to Dayton, Ohio. Excuse me, this is proving the point. How often does the Arctic vortex reach down into Dayton, Ohio? But when you change these convection cells, this is what starts to happen. We're changing the overall weather patterns. And farmers are becoming concerned because now they're being told, hey, this unusual weather we've been having the last several years, this is what you can expect. More of the unexpected. And it's really hard to plan if all you can expect is the unexpected. All right, so yes, there are definitely uncertainties. I cannot tell you, nobody can tell you with certainty how much the convection currents and convection cells will be altered. No one can say with pinpoint preciseness what areas of the globe will specifically be hotter, be colder, be wetter, be drier. How much will the ice sheets melt? How high the sea levels will rise due to thermal expansion of water in the ocean and the melting ice. The degree of that is uncertainty, however. Unfortunately, it is a fact that the overall global climate is changing. And this is once again called the theory of global climate change because in science we only call things theories when there's an overwhelming amount of supporting evidence. And the evidence that supports that climate change is occurring is incredibly diverse. And I will just highlight a few examples for you. For example, the area of the Arctic ice cap. Now, this is not measured by Democrats or Republican. This is the federal government. measures the area of the Arctic ice. And this has to do with national security and when submarines can go back and forth. I mean, this is area that we border Russia with, and at least in spring 2014, Russia has not been behaving very well on a global stage. So this is issues of national security. This is not some environmental extremist here. So as a matter of policy, the government measures the area of the Arctic sea ice, and this is measured in millions of square kilometers. And scientists were shocked when over, 25 years, which is nothing, that's a second in geological time, the area of this region decreased from 7.5 million square kilometers down to 5.5. I mean, that is just crazy to have that much of a decrease. So what is that? That's almost a third, right? Getting there between 25 and 30%. Here we have this huge decrease in the area of the ice in 25 years. And there's no explanation for this, no natural explanation. And scientists were shocked by this, that it was down to 5.5 million square kilometers in 2005 to, oh gosh darn it, I did it again. Until we got to 2007, and here it was down to 4.2. I mean, this just is an alarming rate of change, and there is no natural process that accounts for this. All right, here's another piece of data. This was compiled by a father and son naturalist team in Europe. Again, we're not talking Democrat or Republican. We're talking, all right, this father and son team in Europe. And they were just doing their naturalist job, which is taking data on when flowers bloom over decades. All right, from the 50s to 80s. And look at this. On the average of the spring blooming flowers over their period of observation, they noticed that here the spring blooming flowers were blooming on the average of 2 weeks earlier, almost 2 weeks earlier. And the summer blooming flowers started blooming about a week earlier. All right, the flowers don't read the newspapers. The flowers are not involved with politics. We've seen some mismatch in ecosystems because, again, ecosystem is a tightly evolved unit. We have coevolution evolved together. And now insects have a shorter life cycle. So as the environment changes, the insects will adapt more quickly to a changing environment because they have shorter life cycles. At any rate, other naturalists documented that in the 1980s, and again, that is not that long ago, the peak in caterpillars hatching, all right, right here, the peak in the time of caterpillars hatching from their egg, growing from the egg, exactly matched when baby birds hatched from the egg. So it was great. You had this peak biomass of caterpillars perfectly synchronized when the baby birds were emerging from their eggs and needed more food. But apparently with global warming, this caterpillar time has moved up, and now the caterpillar biomass is declining just when the baby birds are hatching. And so, yeah, some bird populations are having trouble. It's known globally that lots of different populations of organisms are becoming threatened with extinction. All right, we could go on and on, but I have this linked, this hotspot where there is evidence of climate change all over the world from lots of different kinds of data. One example you can read here, if you look on a mountain, as you climb up a mountain higher and higher, it gets colder and colder, right? And it used to be that you could reach a certain elevation and you would not find any more mosquitoes because it was too cold. Well, guess what? That elevation has increased. Now you find mosquitoes at elevations where you never found mosquitoes before. So again, there's documentation that climate change is occurring all over the globe. All right, so more uncertainties. What are the most important, what can individuals do? What can our government do? And I think more important are what actions are absolutely best to take. And maybe a more serious question is what are the consequences of inaction? There's been some updates since I first put together this PowerPoint. And one thing that's been just verified is that it is humans that are driving the climate change. And this is an interesting graph, and you can see this yourself from the Union of Concerned Scientists, and this was taken from the IPCC report, I believe the 2007 version. But basically what it's summarizing is there's a lot of things that influence climate. And like for instance, whenever a volcano erupts, that causes global cooling because particles from the volcanic eruption reflect more energy back into outer space than would normally be reflected. So if you were alive in the early 90s, there was like a major volcanic eruption, and it was early 90s, I forget if it was 91 or 94, that had a cooling effect. And even humans actually exert some global cooling because different pollutants we have actually have a cooling impact on the globe, right? Which is sort of ironic because some of our pollution helps offset global warming. But it's just been very clear from current research that the strongest driver, is what they like to call it, of climate change is the greenhouse gases, which has this very strong warming effect on our planet. And maybe you've heard in the news that human fingerprints are all over the increase in carbon dioxide. So if I can take a minute and explain with that. The two most common isotopes of carbon are C12 and C13. And C12 is, you could call it heavy carbon. It has an extra neutron per nucleus. At any rate, plants prefer to C12 for photosynthesis. So plants have a higher percentage of C12 in their biomass than, let's say, the normal atmosphere. And fossil fuels, remember, are the fossilized remains of dead plants and animals. So if this increase of carbon dioxide is due to the combustion of fossil fuels, then you would predict that as we pump more and more CO2 in the atmosphere due to CO2s, that the percentage of carbon-12 would increase and the percentage of carbon-13 in the atmosphere would decrease. And that is exactly what we've been seeing ever since we started measuring it. So here we see the black line is, this pointer always likes to, the black line is global emissions of carbon dioxide increasing, and the red line is the predicted C13 emissions decreasing. And you're like, what? This red line is going up. Why are you saying that the C12 isotope is decreasing? Because you have to read over here, and these are negative numbers, right? So they just did it this way so you could see the parallel growth, or the parallel between that. So this is a very, very serious issue that affects the whole planet. And on 2007, a question came in front of the UN Security Council: is global climate change a threat to global security? And unfortunately, it appears that it is that suddenly when you have drought where you don't have drought, for instance, then there's less food. That increases the economic instability of some regions that already have political instability. In September 2013, the International Panel on Climate Change, IPCC, came out with the report that really it's, again, since I started teaching this 20 years ago, there was much more uncertainty in the issue of climate change, but now that we've seen the human fingerprint, if you will, and the carbon emissions, it has become very, very clear that yes, we're doing it. We're the ones who are responsible, we humans, for the increased levels of carbon dioxide. And yes, it is not only warming the planet, but is affecting the climate, which is affecting the health of the biosphere. So we will hopefully talk a little bit more about solutions, and I will see you at the next lecture.